Data transmissions. What is data transmission?
Data transmission describes the direction of the flow of signals between two connected devices.
Parallel data transmission.
Parallel data transmission is when several bits of data, like 8 bits, is sent as a whole in one process, simultaneously, on different channels, e.g., wires, frequency channels. This is mainly sent through by a radio path or synchronized to a clock.
Serial data transmission.
Serial data transmission is the process of sending data through computers and CPUs, sequentially, by one bit at a time.
Simplex data transmission.
Simplex transmission refers to data being sent only in one direction, only a one-way communication between the transmitter and receiver.
Duplex and half-duplex data transmission.
Full duplex transmission means that both ends, the transmitter and receiver, can send signals at the same time. Half-duplex transmission refers to being bidirectional communication signals, but they can only flow in one direction at one time.
Differences between serial and parallel data transmission.
Serial data transmission is usually sent sequentially, or better known as sending data one bit at a time. Parallel data transmission is usually sent as several bits of data, in one process simultaneously on different channels. This is completed by using the radio path.
Differences between simplex, duplex, and half-duplex data transmission.
The main difference is that in a simplex mode of transmission the communication is unidirectional, whereas, in the half-duplex mode of transmission the communication is two-directional but the channel is alternately used by both connected devices. On the other hand, in the full duplex mode of transmission, the communication is bidirectional, and the channel is used by both connected devices simultaneously. The main difference.
The need to check for errors.
Error detection are techniques that enable reliable delivery of digital data over unreliable communication channels. Many communication channels are subject to channel noise, and there may be errors introduced during data transmission from the source to a receiver. Error detection techniques allows to detect such errors, while error correction enables reconstruction of the original data.
Understanding the use of serial and parallel data transmission. Integrated circuit, IC.
Integrated circuit. Serial transmission. Many data communication systems were originally designed to connect two integrated circuits on the same circuit board, which are connected by conducting signals on the board. ICs are more expensive when they have more pins. To reduce the number of pins in a package, many of the ICs use a serial bus to transfer data when speed is not that important. Parallel transmission. Parallel transmission in ICs is used in 8 channels for transmission, which allows 8 bits, 1 byte, to be sent simultaneously, which is slower compared to serial transmission.
Understanding the use of serial data transmission in Universal Serial Bus, USB.
USBs are designed to standardize communication with devices such as keyboards, mice, cameras, printers, portable media players, disk drives and network adapters. As serial data transmission is faster than parallel, the USB can transfer or get data faster. They are also more secure as serial transfers data as a whole byte. There is a risk of losing the memory all at once.